Dear student, in this video we will discuss DSC Part 1 Semester 2 Major Paper DSC 4, and the name of the paper is Discrete Probability Distributions. So friends, in this discrete probability distributions there are two units, Unit 1 and this is Unit number 2. In Unit number 1 there are few topics. So that is one topic related is some standard discrete distributions on finite sample space, in which we need to discuss some distributions. The first distribution is one point distributions and the related PMF, mean and variance related to this one point distribution. So there is one more distribution called as 2-point distribution. So in which we need to discuss what is the PMF, mean and variance, the same mean, variance and PMF of this distribution also. So the third distribution is Bernoulli distribution, in which we are interested in finding the probability mass function of Bernoulli distribution and the probability generating function of Bernoulli distribution, and on the basis of probability generating function we need to find out what is the mean and variance of the Bernoulli distribution. In rest of the distribution, on the basis of probability mass function, we are finding mean and variance, wherein in Bernoulli distribution, we are obtaining first probability generating function and then mean and variance. The next distribution is discrete uniform distribution. And in discrete uniform distribution, find out the probability mass function and then mean and variance of the distribution. So therefore, in all, in this some standard discrete distribution on the basis of finite sample space, there are four distributions. These are the four distributions. The number of distributions in this case are four. And what are these distributions? So these distributions are, these are the four distributions. What are those four distributions? The four distributions are 1-point distribution, 2-point distribution, Bernoulli distribution, and discrete uniform distribution. So therefore, the number of distributions in this case are four. And in some standard discrete distribution on finite sample space, there are two distributions. One is binomial distribution and another one is hypergeometric distribution. So therefore, in all, in the first unit, we need to discuss the total number of distributions are 6. First four in the first subunit and the next two are in the next subunit. So 1.2, so that is related with finite sample space 2. So binomial distribution, what is the genesis of binomial distribution? What about the probability mass function? How to find the recurrence relation and the mean and variance and mode of the distribution, skewness, PGF, additive property of binomial variance, and distribution of sum of independent and identically distributed Bernoulli variables. And there are some numerical examples related with this distribution. So this distribution, so binomial distribution is important as far as the literature and the next your advancement in statistics course is concerned. So this distribution plays an important role. So the next distribution is hypergeometric distribution. So what is included in hypergeometric distribution? So what is the genesis of the distribution? How the hypergeometric distribution originated, probability mass function, so these are the parameters, computation, recurrence relation, mean and variance of the distribution, and approximation of hypergeometric to binomial distribution. So these few examples related with hypergeometric distribution we need to understand. So this is the curriculum related with hypergeometric distribution. So the next distribution and the next part of the distributions are in unit number 2. In unit number 2, in all, there are 3 distributions. So Poisson distribution, geometric and negative binomial distribution. So the number of distributions in second unit are 3. So therefore, the total number of distributions. So in first unit there are 6 distributions. In second unit there are 3 distributions. So therefore, the total number of distributions are 9. And this paper is solely related with discrete probability distributions. So what is included in Poisson distribution? So in Poisson distribution, we need to understand the genesis of the distribution, probability mass function, mean and variance of the distribution. So this is mean and variance of the distribution, probability generating function, recurrence relation. So that is also important whenever we are fitting these distributions, additive property of the distribution, and a distribution as a limiting case of binomial distribution. And there are few examples related with Poisson distribution. And what is included in geometric distribution? So probability mass function of the distribution, mean and variance of the distribution, probability generating function, and lack of memory property, and some numerical examples related with geometric distribution. And as far as the negative binomial distribution is concerned, we need to understand how the negative binomial distribution originated, what is the probability mass function of negative binomial distributions, and what geometric distribution as a particular case of negative binomial distribution. The next thing which is very important is mean and variance of the distribution. So that is mentioned here, mean and variance of the distribution, and probability generating function, and also the recurrence relation. See friends, this distribution is, this paper is solely related with uh, the discrete probability distributions. And we need to understand all these discrete probability distributions thoroughly, so that these plays important role in your career in statistics. So thank you very much.